Okay, kids, today we're still working with quadrilaterals, but and you're gonna want to have out your stuff from yesterday about your properties of quadrilaterals, because today you're just classifying, right, based upon the given information and the not given information, right? You can only say that it's one certain type of a thing, okay, one certain type of quadrilateral and or parallelogram. Okay, and we're going to talk about how you should be thinking through this process in order to be able to identify the most correct version of the quadrilateral. Okay, so the first one, it says we have an equiangular quadrilateral. Okay, so equiangular means four equal sides, right? There's four equal angles because it's a quadrilateral, so there's four angles, and it has to, of course, have four sides. So you got to think about, okay, what are all of the shapes that have four equal angles? Okay, and those shapes are a rectangle. Those have four equal angles, and a square. Okay, a square also has four equal angles. Now, in order for it to be a square, we would also have to know that it has four equal sides. Okay, but this just tells us that we have four equal angles. So we don't know enough information to say that it's definitively a square. So all that we can say is that it's definitely a rectangle. Okay, it might be a square, but it is for sure some type of a rectangle. Okay, so an equiangular quadrilateral can be classified as a rectangle. Okay, so our next one says it's a quadrilateral with AC equal to BD. All right, so remember yesterday we talked about how we label these things. So we know it's a quadrilateral, so four sides, right? This is non-specific, so AB and CD. All the way around the outside. And it says AC is the same as BD. So these are diagonals. Okay, so this one is telling you that it has equal diagonals. Now this one is telling you that those diagonals are also perpendicular. Okay, lots of things have perpendicular diagonals and lots of things have equal diagonals, right? Isosceles trapezoids have equal diagonals, rectangles have equal diagonals, squares have equal diagonals, okay? And lots of things have perpendicular diagonals, like kites have perpendicular diagonals, and rhombuses have perpendicular diagonals, and squares have perpendicular diagonals. But there's only one shape that has both equal and perpendicular, and that's going to be a square. Okay, so that's the one that satisfies both of these properties. Equal and perpendicular becomes the square. So this is going to be a square. This is the square. A square is a quadrilateral with equal and perpendicular diagonals. Okay, number 3. This is a parallelogram with, once again, these are equal diagonals. AC and BD are your diagonal lengths. Okay, and it gives us a hint that it's a parallelogram. So there are quadrilaterals like an isosceles trapezoid that do have equal diagonals, but this is saying it's specifically a parallelogram. So the parallelogram with equal diagonals is also going to be a rectangle. Okay, it might be a square, but we don't know enough information to say it's for sure a square. All we know is that it has equal diagonals, and all rectangles have equal diagonals. Okay, number 4. A quadrilateral with bisected diagonals. Okay, so think about all the things that have bisected diagonals. Squares have bisected diagonals, rhombuses have bisected diagonals, rectangles have bisected diagonals, and then of course the parallelograms have bisected diagonals. Now, each one of these squares, rhombuses, and rectangles are all parallelograms, which means that this is a property of all parallelograms. Okay, not any specific parallelogram, but all parallelograms in general. Okay, so we don't know what type of a parallelogram it is, but we know that it's for sure a parallelogram. Okay, so if you want to, pause the video here and work through the rest of them. Okay, work through all these other things so that you can try and figure them out, right? And then come back and listen to the video once you're done trying to figure out all these other things and see if you got them right. Okay, take a chance and try it on your own. I'm going to continue though. So we have a quadrilateral with congruent diagonals. Okay, or equal diagonals here. We'll say equal since there's an equal sign. Okay, so those quadrilaterals that have equal diagonals are your square, right? They have equal diagonals. Your rectangle has an equal diagonal, as do your isosceles trapezoids. Okay, these are all of the quadrilaterals that have equal diagonals. Okay, now we don't know that it's a parallelogram, so we can't say that it's a rectangle or a square. Okay, so the only thing that we can say definitively about this shape is that it is for sure an isosceles trapezoid. If we knew it had opposite sides that are the same, then it would be one of these other ones. But all we know is that it has congruent diagonals, so it can be an isosceles trapezoid. Okay, quadrilateral with, well, here we have some parallel sides, right? So it's definitely a parallelogram. And this one says that the diagonals are perpendicular. So think about the parallelograms that have perpendicular diagonals. Okay, and those are your rhombus. A rhombus has perpendicular diagonals, and your square are the two parallelograms with perpendicular diagonals. Okay, now we don't know enough information once again to say it's a square. All we know is that they're perpendicular. So that's all we can say is that it's a rhombus. Right? A square is a special rhombus, so it's got to be some type of a rhombus. Okay, number 7, we have a quadrilateral with one set of parallel sides. Okay, one set. Nothing else do we know about any other sets. So for sure, we know that this is a trapezoid. Okay, it might be something else if we knew other information, but if all we know is that it has one set of parallel sides, then all we know is that it can be a trapezoid. Okay, not even a special trapezoid, just a trapezoid. Okay, number 8 is a quadrilateral with AB, BC, CD. So that means all of the sides are equal. Okay, 4 equal sides. So think about your quadrilaterals that have 4 equal sides. Okay, and those are going to be, once again, your rhombus has 4 equal sides, and your square has 4 equal sides. Okay, now hopefully you're getting the idea that there's probably not enough information to say it's a square, because squares have more than just 4 equal sides, which means this is going to be a rhombus. Okay, it might be a special rhombus, but we don't know that, so all we can say is that it's for sure a rhombus. Okay, 9, a quadrilateral with AB is equal to CD. Okay, so that's one set of opposite sides. And BC and AD, so those are the diagonals, right? We have a set of a quadrilateral with opposite sides that are equal and diagonals that are congruent. Okay, so this is a very bad picture because, of course, the diagonals probably aren't congruent here. So opposite sides are equal and congruent diagonals. Okay, so that happens in a couple of things. That happens in a rectangle. That happens in a square. But that also happens in an isosceles trapezoid. Right? The legs are across from each other. The legs are congruent. They're opposite sides in a quadrilateral, in an isosceles trapezoid. And they also have congruent diagonals. Okay, so we don't know about the other 2 sides. We only know about one set of sides. So that means this can only be an isosceles trapezoid because it only says it has one set of congruent sides, not 2 sets like rectangles and squares need. So isosceles trapezoid is the answer for that one. Okay, let's see about number 10. A quadrilateral with AB and CD, BC and AD. Okay, so that's all 4 sides, right? The opposite ones are congruent. and we have diagonals. So this says opposite sides, and this one is diagonals. Okay, so because we know this piece of information, we can say that it's a rectangle, because rectangles have opposite sides that are congruent, because it's a parallelogram, but it also has congruent diagonals. Okay, now if we knew something about the if they were equal to each other, maybe it could be a square. But just because we have opposite sides equal, that's going to make it into a rectangle. Okay, and 11, a quadrilateral with AC and BD. Remember, these are your diagonals, AC and BD. So we have equal diagonals and we have perpendicular diagonals. Okay, this only happens in a square. They're equal in a rectangle and they are perpendicular in a rhombus. But if you put them both together, a rectangle and a rhombus, you get a square. So this one is going to be a square. Okay, so now we're going to throw in some algebra into this. A parallelogram with congruent diagonals. So a parallelogram with congruent diagonals is a rectangle. Okay, so we draw in your rectangle. Remember, we have our 4 points, A, B, C, and D. And E is the intersection of their diagonals. Okay? E is the intersection of the diagonals of your quadrilateral. So E goes there. So now let's put in your values. We have A to E is 5. A to B is 6. And B to C is x plus 5. So one of the properties of a rectangle is that the diagonals bisect each other. So if A to E is 5, that means E to C is 5. Okay, and another property of a rectangle is that it has a 90-degree angle in the corner. So we have ourselves a nice right triangle with a side of 6. So we're going to use Pythagoras. 6 squared plus x plus 5 squared equals 10 squared, because 10 is the entire length of that rectangle, or that hypotenuse. The diagonal is going to be 10. So now we have ourselves a little problem to solve. Okay, so we're squaring the binomial. Remember, that means multiply it by itself. And we get these three terms when we multiply it by itself equals 100. And now that we have a quadratic, we're going to get everything onto one side and solve it by factoring. Okay, so 25 and 36 is 61. Okay, and then minus 100 becomes x squared plus 10x minus 39 equals 0. So this is going to be hopefully factorable. We're going to try and factor it. What numbers multiply to give us negative 39 and add to give 10? Okay, and you might need to think about it for a second, but those numbers are 13 and 3. 13 times 3 is 39, and 13 minus 3 is 10. So now this becomes, sorry, I don't have any more space. I'm going to come up here with it. This factors to x minus 3 and x plus 13 equals 0. Okay, so if x minus 3 equals 0, that means x equals positive 3. And if x plus 13 equals 0, x equals negative 13. And because this is geometry, we can't have a negative length, so we throw out the negative 13. So in other words, x equals 3 is the solution to this problem for number 12. Okay, and then try for yourself number 13. Okay, in fact, this is going to be your answer for your question today. Okay, a quadrilateral with AC perpendicular to BD. Okay, so this is going to be a kite. Okay, let's draw for you your kite. It's a quadrilateral. Here's your kite. We'll start it set up like this, but your job is to answer this question. Here is A and B and C and D. AB and CAD is 20, so these two sides are 20. And the measure of angle A is 140 degrees. Okay, so there's some things that you need to think about as you're solving this problem. Okay, so you're going to give me the answer, and this is what's going to go into your discussion question. Oh, look, there's the bell. Okay, so some properties of your kite that we discussed yesterday. Here's A and B and C and D. Right, this whole entire thing is 140. Now, maybe you remember, maybe you don't, but the non-congruent angles get bisected. So this becomes 70 degrees, and this bottom one becomes 70 degrees. Okay, because this is a right triangle here, this top angle is going to be 20. Okay, so if we know that the side is 20 here, we can use trig in order to figure out this height, this length here. And also we can figure out what this is here. But I believe, let's go back for a second to see what your answer says. You just want to find the length of BD. Okay, so you don't need to figure out what Y is. You just need to solve for X, right? The opposite side for this right triangle. And then this side down here is also X, so you add them together, and that gives you the length of BD. Okay, make sure you are rounding to 3 decimal places. So that is your answer to your discussion question for your attendance today. Okay, so when you're doing quadrilaterals, what you know or what you don't know is just as important as what you do know. Have a fantastic weekend.